Here's an inequality, 3x plus 1 divided by x minus 1 is greater than 5. What I'd like you to do is have a go at solving this. So you can pause the video and try and solve it. Okay, here's the solution, and this is the way most people do it. 3x plus 1 greater than, let's times both sides by x minus 1. Go through that. Let's take away 3x from both sides. Let's add 5 to both sides, and here is our solution. So x is less than 3, which is fine, but let's try a number in there that's less than 3. So let's make x equal to 0. And let's put it into here and see if it'll work. So when x is 0, I'll have 1 on the top, and minus 1 on the bottom, and that is not less than 5. Sorry, it's greater than 5. That is not greater than 5. So that will not work into the original inequality. And furthermore, I can show you using the graph why it won't work. So here's my graph of the equation, and here's y equals 5, and this is an asymptote at x equals 1. Let's just label that on there. And here is the intersection point where x equals 3. So this was the one that I got from my inequality. But where is this graph greater than 5? Clearly, with a graph, I can see that it's only this part here. So it stops here at 1. So it's between 1 and 3. Let's go back and think how we could do that if we didn't have a graph. Well, I can see here that one of my special points is 3. But let's look at this and think about what number x cannot be here. And that's 1, because we can't divide by 0. So I call these 2 points critical points, and I'll make a number line with these 2 critical points. So on here, I'm going to put 3, because that was from my inequality. And I'm going to put 1, because that was one of the numbers it couldn't be. And I'm going to test these 3 regions. Now, I've already put x as 0 in here, which is in this region, and nothing works. Now I'm going to put x as 2 in to the original inequality and see if that will be true. So when 2 goes in, I have 3 times 2 plus 1, which is 7, divided by 2 take away 1, so that's going to give me 7, greater than 5. Yes, it works. Okay. And now I'm going to put 4 in. If I put 4 into there, I'm going to have 12, 13 on the top, 4 on the bottom going in is going to give me 3 on the bottom, greater than 5. Guess what? We know from our graph that that region doesn't exist. So actually, without a graph, I can do this by looking for a critical point and a critical point, use a number line, and say that the only x values are when x is less than 3 and when x is greater than 1. So this is my final answer. If you have access to a graphic calculator, it's very simple just to do this on your graphic calculator and you get the answer straight away. But if it's a non-graphic calculator question, then you have to do this.